Welcome to Lost in Disclosure. Tonight, we drift into the deep water. Chapter 1, The Sound That Woke the Silence. Not the water you see from shore, sunlit and gentle, breaking in white foam against familiar sand. No, tonight we descend past the reach of light, past the last whisper of warmth, into the cold, black silence where pressure becomes a presence and darkness takes on weight. Down here, in the deepest trenches of our world's oceans, there exists a kind of stillness that predates humanity. A quiet so profound, it seems to hold memory of ancient currents, of mountains swallowed whole, of creatures that lived and died before we ever walked upright beneath open sky. And yet, this silence is not empty. For decades, listening devices scattered across the ocean floor have captured something extraordinary. Not the songs of whales, though those too echo through these waters, not the grinding of tectonic plates, though the earth does speak in its slow, patient way. These are sounds that defy easy explanation, frequencies that appear suddenly in the data, powerful and precise, originating from coordinates where nothing should exist. Some call them anomalies. Others, with voices lowered and eyes distant, call them signals. In 1997, a hydrophone array operated jointly by NASA and the National Oceanic and Atmospheric Administration detected an ultra-low frequency sound of such immense volume that it was recorded by sensors over 3,000 miles apart. The waveform, when visualized, looked almost biological. A rising tone, a peak, then a slow, haunting descent. Scientists named it the Bloop. They said it resembled the call of a living creature. But no creature on Earth, no whale, no giant squid, no unknown leviathan of the deep should be capable of producing sound at such magnitude. The ocean, it seems, has a voice, and we are only beginning to learn its vocabulary. This is not a story of certainty. It is not a narrative with neat conclusions or comfortable answers. It is instead an exploration of the spaces between what we know and what we wonder. A journey into the blue-black depths where science meets mystery and where the boundaries of the known world begin to blur. Over the next hour, we will follow the trail of these inexplicable sounds. We will listen to the recordings, examine the data, and consider the theories, from the plausible to the extraordinary. We will meet the scientists who spend their lives decoding the ocean's secrets, and we will ask the questions they ask in the quiet hours, when the instruments fall silent and only speculation remains. What made these sounds? Where do they originate? And perhaps most unsettling of all, are they still happening? The hydrophones that captured the Bloop were not designed to hunt for mysteries. They were built for a different purpose entirely. Remnants of Cold War technology, listening posts meant to track the movements of submarines beneath hostile waters. When the Soviet Union fell and the threat receded, these arrays were repurposed for science, their sensitive ears turned toward the natural world. What they heard was not what anyone expected. Imagine for a moment the scale of this discovery. The Pacific Ocean alone covers more than 60 million square miles. Its average depth exceeds 2 miles, and in places, the Mariana Trench, the Tonga Trench, the Philippine Deep, the seafloor plunges to depths that exceed the height of Mount Everest above sea level. These are landscapes more alien than the surface of Mars, less explored than the far side of the Moon. And somewhere within this vast three-dimensional wilderness of water, something spoke. The recordings themselves are strange to hear. When played at normal speed, many are too low for human ears to detect. Subsonic rumbles that you feel more than hear, vibrations that resonate in your chest and remind you, uncomfortably, of how small you are. When sped up 16 times, however, they become audible. The bloop transforms into a sound that is oddly organic, almost plaintive, a call rising from depths we cannot see, searching for a response that may never come. Some who hear it describe a feeling of recognition, as if the sound triggers something primal in the human brain, an ancient warning perhaps, coded into our DNA from a time when our ancestors were prey and the ocean was a boundary we dare not cross. Others hear only data, frequency, amplitude, duration, numbers on a graph, patterns in a spectrogram, science stripped of romance. But even scientists, in their most honest moments, will admit that mystery has a pull, that standing before the unknown, clipboard in hand and mind full of theories, they feel something beyond curiosity. They feel wonder. And sometimes, late at night, in the glow of a monitor, they feel a whisper of unease. Because the ocean is not empty. It is full of movement, full of life, full of processes we only dimly understand. And if it can hide something capable of producing a sound like the bloop, a sound that travels thousands of miles and shakes the instruments designed to measure it, then what else might it conceal? This question haunts the margins of oceanography. It lives in the footnotes of research papers and the unspoken thoughts of scientists who have spent decades mapping the seafloor, cataloging species, measuring currents and temperatures and chemical compositions. The ocean gives up its secrets slowly, reluctantly, and often in fragments that raise more questions than they answer. The sounds are like that, fragments, pieces of a larger puzzle that may not have a picture on the box. So tonight, we begin with a sound, a single strange tone captured by machines listening in darkness, preserved in digital archives, and waiting for us to understand, or waiting, perhaps, for us to simply listen.
Chapter 2. Echoes from a Hidden World. To understand the mystery, we must first understand the medium. Sound, in water, behaves differently than it does in air. It travels faster, nearly 5 times faster, and it travels farther, especially at certain depths, where temperature and pressure create natural channels called sound ducts. In these acoustic highways, a low-frequency noise can circle the entire planet, bouncing between layers of water like a whisper passed down an endless hall. This is the ocean's secret. It is not silent. It is, in fact, one of the loudest environments on Earth. If you could sink beneath the waves with ears capable of hearing across the full spectrum of frequencies, you would be overwhelmed by noise. The crack and pop of snapping shrimp, which collectively produce more sound than all other marine life combined. the groaning of ice shelves as they calve enormous bergs into polar seas, the rhythmic scrape of sand rolling along the seafloor during storms, the eerie, mournful songs of humpback whales transmitted across entire ocean basins to be heard by others of their kind 1,000 miles away. And beneath it all, the deep bass rumble of the earth itself, volcanic vents hissing and boiling, undersea earthquakes releasing tension along fault lines, the slow, patient grind of continental plates drifting across the mantle. This is the soundscape that hydrophones capture. This is the symphony that scientists must learn to interpret, distinguishing the ordinary from the extraordinary, the known from the unknown. The technology itself is elegantly simple. A hydrophone is essentially an underwater microphone, converting pressure waves in the water into electrical signals that can be recorded and analyzed. The arrays used by NOAA and other research organizations consist of multiple hydrophones placed at strategic locations across the ocean floor, often in the deep sound channel, where ambient noise is minimized and distant signals are amplified. During the Cold War, the United States Navy deployed an extensive network of these listening stations, collectively known as SOSUS, the Sound Surveillance System. Its purpose was military, to detect Soviet submarines, to track their movements, to maintain an acoustic map of the ocean that could provide strategic advantage in the event of conflict. But when the Cold War ended, a remarkable transformation occurred. The Navy partially declassified SOSUS and began sharing its data with civilian scientists. Suddenly, oceanographers had access to a listening network of unprecedented scale and sensitivity, a tool that could reveal not enemy vessels, but the hidden life and dynamics of the ocean itself. And that's when the strange sounds began to appear. At first, they were dismissed as instrumental glitches or misidentified natural phenomena. The ocean, after all, is full of surprises. Underwater slide sheds can generate powerful low-frequency pulses. Icebergs grinding against the seafloor producing haunting tones. Even the migration patterns of certain fish species create detectable acoustic signatures. But some sounds refused to fit neatly into known categories. They appeared without corresponding seismic activity. They originated from locations where no ice exists. They repeated with a regularity that seemed purposeful, almost rhythmic, yet lacked the clear biological signature of whale or dolphin communication. Dr. Christopher Fox, chief scientist at NOAA's Pacific Marine Environmental Laboratory, was among the first to publicly acknowledge these anomalies. In interviews, he speaks carefully, weighing each word, a scientist acutely aware that speculation can undermine credibility. Yet even his cautious phrasing cannot entirely mask a sense of wonder. He explains in one archival interview, his voice measured and calm. "We've identified many of the sources, but there are still sounds in our database that we cannot definitively explain. The ocean is vast. There are species we haven't discovered yet, geological processes we don't fully understand. These sounds remind us how much we still have to learn." It is a diplomatic answer, a scientist's answer.
But in the pauses between his words, in the slight furrow of his brow when pressed for details, there is something else, a recognition, perhaps, that the ocean holds more than undiscovered species and unexplained geology. It holds genuine mystery. The recordings themselves are publicly available, archived on NOAA's website for anyone to download and analyze.
Citizen scientists, amateur enthusiasts, and conspiracy theorists have pored over these files, applying their own theories and interpretations. Some hear messages, others hear warnings. A few claim to detect patterns, mathematical sequences, repeated intervals, structures too precise to be random. The scientific community approaches such claims with skepticism, and rightly so. The human brain is exceptionally good at finding patterns, even where none exist. We see faces in clouds, hear words in static, and impose meaning on randomness, because meaning is comforting, chaos is not. Yet skepticism, taken too far, becomes its own kind of blindness. The sounds are real, the recordings exist. Something generated those frequencies, sent them traveling through thousands of miles of ocean, and triggered sensors with enough force to be measured, analyzed, and preserved. To dismiss them entirely is to ignore the evidence. To accept them uncritically is to abandon reason. The truth, as always, lies somewhere in the tension between these extremes, in the careful, patient work of scientists who listen without prejudice and analyze without assumption, who remain open to wonder while anchored to method. This is the world we enter now, a world of data and mystery, of hydrophones and hypotheses, of sounds that rise from the deep and leave us questioning everything we thought we knew about the ocean. Because the ocean, for all our technology and exploration, remains largely unknown. We have mapped its surface with satellites and charted its major features with sonar. But the deep, the true deep, where pressure crushes steel and darkness is absolute, remains as alien and unexplored as the far reaches of space. And if the ocean can hide sounds like these, transmitted across its vast expanse with power and clarity, then what else might it conceal? What other voices might be calling from the abyss, waiting for us to develop ears capable of hearing them? Chapter 3. The Bloop. It happened on a summer day in 1997, though in the deep ocean there are no seasons, only the eternal cold and the pressing dark. Multiple hydrophones in the Pacific, separated by thousands of miles, detected it simultaneously. An ultra-low frequency sound, rising rapidly in frequency over the course of approximately 1 minute, then fading back into silence. The signal was powerful enough to be triangulated, its origin point calculated to lie near 50 degrees south, 100 degrees west, a remote location in the South Pacific, west of the southern tip of South America, deep in the waters off Antarctica. When scientists played the recording at normal speed, it was inaudible, too low for human hearing. But when they accelerated it 16 times, it became something both fascinating and deeply unsettling. It sounded alive. The waveform bore a striking resemblance to biological sounds, the calls of marine mammals specifically. There was an organic quality to it, a rise and fall that seemed almost intentional, almost communicative. It was this characteristic that led scientists to name it the bloop, a descriptor that somehow captures both the strangeness and the oddly whimsical nature of the phenomenon. But the volume, the sheer acoustic magnitude of the bloop was incompatible with any known biological source. The blue whale, the largest animal ever to exist on Earth, produces sounds that can reach 188 decibels and travel hundreds of miles underwater. Blue whale calls are among the loudest biological sounds on the planet, powerful enough to be detected across entire ocean basins. The bloop was significantly louder. For a living creature to produce such a sound, it would need to be substantially larger than a blue whale, an animal of almost unimaginable size, something that would rewrite our understanding of marine biology, and perhaps challenge the physical limits of what aquatic life can achieve. No such creature has ever been observed. No carcasses have ever washed ashore that would suggest its existence. No sonar contact, no underwater footage, no credible eyewitness account has ever documented anything remotely large enough to be the source of the bloop. And yet, the sound exists. Recorded, archived, analyzed. In the years following the detection, theories multiplied. Online forums buzzed with speculation. Cryptozoologists seized upon the bloop as evidence of undiscovered megafauna, perhaps a surviving population of prehistoric marine reptiles, or a species of giant cephalopod far exceeding the size of known giant squids.
The idea has a romantic appeal. The ocean, after all, has surprised us before. The coelacanth, a fish thought extinct for 66 million years, was discovered alive and well in 1938. Giant squids, once dismissed as sailors' myths, were eventually confirmed to exist, with specimens measuring over 40 feet in length. Even in recent years, new species are discovered regularly, strange, alien-looking creatures adapted to the crushing pressures and total darkness of the abyssal zones. Could there be something larger still? Something that dwells in the deepest trenches, surfacing only rarely, generating sounds that we detect but whose source remains hidden? It's a compelling thought, but science demands more than compelling thoughts. It demands evidence. And the evidence, when carefully examined, points elsewhere. In 2005, after years of analysis, NOAA scientists proposed a more mundane explanation: ice quakes. Specifically, the sound of massive icebergs cracking and fracturing as they calve from Antarctic ice shelves, then grind against the seafloor as they drift and settle. The location of the bloop's origin, near Antarctica, in an area dense with icebergs, supported this hypothesis. So did the acoustic profile, which, upon closer examination, matched other known ice-related sounds. When ice under tremendous pressure fractures, it releases energy in the form of powerful acoustic waves. These waves, traveling through water, can be detected thousands of miles away. The mystery, it seemed, was solved. And yet, many who hear the bloop, even knowing the official explanation, find it difficult to shake the sense that something more is at play. There is a quality to the sound, a modulation, a structure that seems purposeful. Not like ice cracking, which tends to be sharp and chaotic, but like a call, a signal. Perhaps this is simply the human tendency to anthropomorphize, to project intention onto natural phenomena. We have always done this, seen gods in storms, heard voices in wind, interpreted the random movements of stars as messages meant specifically for us. Or perhaps, occasionally, our instincts point us toward truths that data alone cannot fully capture. The scientist who listens to the bloop hears ice. The dreamer hears something else. And the ocean, indifferent to both, continues to guard its secrets. There's a philosophical question embedded in all of this, a question that extends beyond marine biology and into the nature of knowledge itself. How do we determine truth when our tools are limited and our experience is incomplete? We cannot explore every trench. We cannot monitor every square mile of ocean floor. We cannot be everywhere at once, witnessing every event, cataloging every sound. We rely on instruments, hydrophones, sonar, satellites to extend our senses, to capture data from places we cannot physically go. But instruments are only as good as their design and our interpretation of their output. When a hydrophone records the bloop, it captures frequency, amplitude, duration. It does not capture context. It does not tell us what we're listening to, only that something occurred. The rest, the identification, the explanation, the narrative we build around the data, is interpretation. And interpretation is always, to some degree, an act of faith. We have faith in the scientific method, in peer review, in the accumulated knowledge of generations of researchers who have painstakingly built a framework for understanding the natural world. This faith is generally well placed. Science has given us everything from antibiotics to space travel, from an understanding of evolution to the technology that allows us to peer back to the first moments after the Big Bang. But science also has limits. It can tell us that the bloop likely originated from ice based on acoustic profiles and geographical data. It cannot tell us with absolute certainty that this is the only explanation, or that there is nothing else in those waters capable of producing similar sounds. It cannot prove a negative. And so the mystery, officially solved, continues to linger in the minds of those who wonder, who listen to the recording late at night and think, what if? What if the explanation is incomplete? What if there is more to the story? What if, in the cold black water off Antarctica, something immense and unknown stirred once in 1997, called out into the void, and then descended again into silence? We may never know, but the question remains, drifting through the dark water like the echo of a sound heard only once, impossible to forget.
Chapter 4. Whistle, Julia, and Slow Down. The bloop was not alone. In the years surrounding its detection, NOAA's hydrophone arrays captured several other anomalous sounds, each with its own distinct character, each defying easy explanation. They were given names, informal designations chosen by the scientists who first analyzed them, names that attempted to capture something essential about the audio signature. There was Whistle, detected in July 1997, just weeks after the bloop. A sharp, ascending tone that rose from lower frequencies to higher ones over the course of several seconds, then vanished. Clean, almost pure in its frequency sweep, it resembled no known biological or geological source. Its origin point was traced to the eastern Pacific, but no corresponding seismic activity was recorded, no ships were in the vicinity, no obvious source could be identified. Then there was Julia, recorded in March 1999. This sound was different, longer, more complex, with a descending frequency that gave it an almost mournful quality. When played at accelerated speed, it seemed to warble and distort, as if the source was moving or the medium was changing. The sound lasted for approximately 15 seconds and was loud enough to be detected across the entire equatorial Pacific Ocean autonomous hydrophone array. Speculation about Julia ranged from the biological, perhaps an unknown cetacean species, to the geological. Some researchers suggested it might be the sound of a massive iceberg running aground, its frozen bulk scraping against an undersea mountain. Others noted the descending pitch and wondered if it could be something metallic, something man-made, sinking slowly into the abyss. No consensus was reached. And then there was Slow Down, detected in May 1997. Its name describes its defining feature, a sound that begins at a higher frequency and slowly, steadily decreases over a period of about 7 minutes. The waveform, when visualized, looks almost like a sigh, a long, gradual exhalation of energy fading into the background noise of the ocean. Slow Down was eventually attributed to ice, specifically the sound of icebergs breaking apart and grinding against the seafloor, a process that can generate acoustic signatures lasting several minutes. This explanation is consistent with the location, near Antarctica, and the acoustic profile, matching other known ice-related sounds. But like the bloop, Slow Down retains a kind of mystique that transcends its official explanation. There is something haunting about a sound that fades so slowly, as if whatever created it was reluctant to fall silent, clinging to audibility for as long as possible before disappearing entirely. These sounds, bloop, whistle, Julia, Slow Down, are part of a larger catalog of oceanic anomalies, a collection of audio recordings that represent the outer edges of our understanding. They are the sounds that don't fit neatly into categories, that resist simple identification, that linger in databases and in the minds of scientists who encounter them. Some have since been explained. Others remained unresolved. What unites them is not their source, but their effect. They remind us, in the most visceral way possible, that the ocean is not fully known. That despite our technology, our exploration, our centuries of study, there are still phenomena we cannot account for, still mysteries that elude explanation. Each sound, in its own way, is a kind of message, not from an intelligence, not from a consciousness attempting to communicate, but from the ocean itself, a reminder of its scale, its depth, its capacity to surprise us. Let's linger for a moment on Julia, because it represents something important about how science interacts with mystery. When Julia was first detected, it generated significant interest. The sound was unusual, its source unclear, and the lack of an obvious explanation invited speculation. Forums and websites dedicated to unexplained phenomena latched on to Julia as potential evidence of unknown marine life, secret military operations, even extraterrestrial activity, a theory that requires several leaps of logic, but one that emerged nonetheless. For years, Julia remained officially unexplained. It sat in the database, a curiosity, a puzzle.
Then, in 2008, a research team analyzing iceberg activity near Antarctica published findings that suggested a likely source: tabular icebergs, massive, flat-topped ice structures that calve from ice shelves, produce complex acoustic signatures when they crack, roll, or collide with underwater topography. The frequency profiles of these events closely matched several anomalous sounds in NOAA's database, including Julia. The explanation was accepted by most of the scientific community. Julia was reclassified as likely ice-related. But here's what's interesting. The explanation is probabilistic, not definitive. No one witnessed the specific iceberg event that generated Julia. No satellite imagery captured the moment of its creation. The conclusion is based on pattern matching, comparing the characteristics of Julia to the characteristics of known iceberg sounds and finding sufficient similarity to assign causation. This is often how science works, particularly in fields like oceanography, where direct observation is difficult or impossible. We build models based on available data, we compare unknowns to knowns, and we assign the most probable explanation. Most of the time, this approach is correct, but most probable is not the same as certain. And in the gap between probability, mystery survives. This is not an argument against the ice hypothesis. It is, in all likelihood, the correct explanation for Julia, for slowdown, for the bloop. Ice is common in the regions where these sounds originate. It is massive, energetic, and capable of producing powerful acoustic events. The match between observed sounds and known ice signatures is strong. But acknowledging the most likely explanation does not require us to abandon wonder. It does not mean we must stop asking questions or considering alternatives. Science, at its best, is a process of continuous refinement, of holding current explanations lightly, remaining open to new data, and being willing to revise our understanding when evidence warrants. The sounds, even if explained, remain extraordinary. They are acoustic records of events occurring in one of the most remote and inhospitable environments on Earth, events that release energy equivalent to small earthquakes, that generate signals detectable across entire oceans, that speak to the immense power and dynamism of natural processes we rarely witness directly. To hear Julia is to hear the planet at work. To hear slowdown is to hear time made audible, minutes condensed into a single fading tone. And to hear the bloop, regardless of its source, is to confront the limits of human knowledge and the vastness of what remains unknown. These sounds are, in a sense, the ocean's poetry. Not words, not language, but expression nonetheless. The acoustic fingerprint of a world beneath the waves, a world that operates according to its own rhythms, indifferent to our observation, yet endlessly fascinating when we take the time to listen. There is a lesson here, perhaps, about humility, about the importance of listening without presumption, of observing without immediately categorizing, of allowing mystery to exist even in the presence of explanation. Because even if every anomalous sound in NOAA's database is eventually traced to ice or geology or known biology, the fact remains, we did not know. For years, decades in some cases, we did not know. And if the ocean could hide these truths from us for so long, what else might it be concealing? What other sounds are being generated right now, in trenches too deep for our current arrays, in frequencies our instruments are not designed to detect? The catalog of known unknowns is extensive. The catalog of unknown unknowns is by definition infinite. And somewhere in that infinite space, the ocean continues to speak.
Chapter 5. The Listeners. Behind every mysterious sound, every anomalous reading, every unexplained signal, there are people. Scientists, technicians, analysts, individuals who spend their days and nights listening to the ocean, interpreting its voice, trying to separate meaning from noise. They are not adventurers in the traditional sense. They do not dive into the abyss or pilot submersibles through crushing darkness. Their exploration happens in rooms lit by the soft glow of monitors, where spectrograms scroll endlessly across screens and audio files accumulate in vast digital libraries. It is quiet work, patient work, the kind of labor that requires a particular temperament, an ability to find fascination in repetition, to remain alert during long hours of routine, to recognize when something subtle but significant appears amid the ordinary. Dr. Christopher Fox, whom we mentioned earlier, has spent decades in this pursuit. His office at NOAA's Pacific Marine Environmental Laboratory in Oregon is filled with the tools of modern oceanography: computers, hard drives, binders full of research papers. But on the walls, there are also photographs of the sea: waves breaking against rocky shores, storm clouds gathering over dark water, the endless blue horizon where ocean meets sky. In interviews, he speaks about the sounds with a mix of scientific precision and barely concealed wonder. He explains the mechanics of hydrophone arrays, the process of acoustic triangulation, the challenges of filtering signal from background noise. But there are moments when his explanations pause, when he seems to be listening to something beyond the words he is speaking. "You have to understand," he says in one conversation, "that the ocean is constantly making noise. Every recording contains dozens, sometimes hundreds of distinct sounds overlapping and interfering with each other. Our job is to isolate the anomalies, the sounds that don't fit the patterns we know. And when you find one, when you play it back and realize you're hearing something that no one has identified before, it's humbling." Humbling. It's an interesting word choice. Not exciting, not thrilling, but humbling. Perhaps that's the appropriate response to mystery, not triumph, but a quiet recognition of how much remains beyond our grasp. The work of these scientists is often solitary, but it's not lonely. There's a community, small, specialized, but deeply connected, of researchers around the world who share data, compare findings, and collaborate on interpretations. They attend conferences where presentations focus on frequency analysis and acoustic modeling. They publish papers with titles like "Long-Range Acoustic Detection of Iceberg Calving Events" and "Characterization of Ultra-Low-Frequency Ocean Ambient Noise." But in the margins of these professional gatherings, in the hallways between sessions, the conversations sometimes drift toward the unexplained, toward the sounds that resist classification, toward the possibility, however remote, that something truly unknown might be out there. These are careful conversations. Speculation in science carries risk, the risk of appearing credulous, of damaging one's reputation, of being dismissed by peers. So the speculation is framed hypothetically, wrapped in caveats, expressed as open questions rather than assertions. But it happens because curiosity is stronger than caution, and wonder is part of what drew these individuals to the ocean in the first place. One researcher, speaking anonymously, describes the experience of working through the NOAA's sound archive late at night. You put on headphones and you start going through files. Most of it is background noise, the ambient hum of the ocean. But every now and then, you hear something that makes you stop, something that doesn't sound like anything else, and you think, what was that? Where did it come from?
She describes checking timestamps, cross-referencing sensor data, looking for corresponding seismic activity or weather events. Sometimes an explanation emerges. The sound matches a known source. The mystery resolves. But not always. There are files I've gone back to multiple times, she admits, just listening, trying to hear something I missed the first time. Some sounds, they just stay with you. This is the human element of the story, The fact that scientific exploration is not conducted by machines alone, but by people who bring their own experiences, intuitions, and emotions to the work. People who can analyze data dispassionately while also feeling the pull of mystery, the allure of the unknown. It's a balance, and not always an easy one. The scientific method demands objectivity, but human beings are not objective creatures. We have biases, hopes, fears. We see what we expect to see, hear what we want to hear. This is why peer review exists, why replication is essential, why extraordinary claims require extraordinary evidence. But science also requires imagination, the ability to look at data and envision possibilities, to ask what if, and follow that question wherever it leads. Every major discovery begins with someone noticing something unusual and having the courage to investigate further, even when the conventional wisdom suggests there's nothing worth investigating. The sounds recorded in the ocean are a reminder that there is still room for discovery, still space for the imagination to operate within the framework of rigorous science. And the people who do this work, who spend their lives listening to the ocean, interpreting its signals, maintaining the instruments that extend our senses into the deep, are, in their own quiet way, explorers. They may not travel to distant shores or plant flags on uncharted territory, but they venture into the unknown nonetheless. They map the acoustic landscape of a world we cannot see, translating sound into meaning, noise into knowledge. And sometimes they encounter mysteries that resist translation. The hydrophone arrays that captured the Bloop and its companion anomalies are still operational. They continue to listen, day after day, year after year, recording the ocean's endless symphony. New sounds are detected regularly, some identified immediately, others added to the catalog of unknowns awaiting explanation. The scientists who monitor these arrays know that most anomalies will eventually be explained, that the vast majority of mysterious sounds will, with time and analysis, reveal mundane origins. But they also know that most is not all, and so they keep listening. Not in expectation of discovering sea monsters or alien signals or evidence of the impossible, but with the more modest hope of learning something new about the planet we inhabit, of expanding the boundaries of knowledge by careful increments, of being present when the ocean chooses to reveal another of its secrets. This is the patient work of science, listening, observing, questioning, analyzing, not for glory or headlines, but for the quiet satisfaction of understanding a little more today than we did yesterday. And in that work, there is a kind of poetry. The ocean speaks, we listen, and slowly, word by word, sound by sound, we begin to comprehend the language of a world that has been speaking all along, waiting only for us to develop the tools and the patience to hear it.
Chapter 6. Beneath the Ice. Antarctica. The name itself evokes extremes, a continent of ice and wind, where temperatures plunge to levels that would freeze human flesh in minutes, where vast ice shelves extend hundreds of miles from shore, and where the ocean beneath is as dark and cold as space. It is also, perhaps not coincidentally, the region where many of the most enigmatic ocean sounds have been detected. The bloop originated here. So did slow down, and several other unidentified signals. The location is not random. Antarctica is geologically and acoustically active, a place where ice and water and rock interact in ways that generate powerful acoustic events. But it is also a place of profound isolation and mystery. Beneath the ice shelves, some more than a mile thick, lie bodies of water that have been sealed off from the surface world for millennia. Subglacial lakes, hidden beneath crushing weight, where liquid water persists in total darkness, fed by geothermal heat from the Earth's interior. Lake Vostok, the largest of these hidden lakes, lies beneath more than 2 miles of ice. It is roughly the size of Lake Ontario, and it has been isolated from the atmosphere for an estimated 15 million years. What lives in Lake Vostok, if anything, remains unknown. Russian scientists drilled down to its surface in 2012, but contamination concerns and the difficulty of exploring such an extreme environment have limited what we've been able to learn. Other subglacial lakes exist across Antarctica. More than 400 have been identified through radar surveys and satellite measurements. They form a hidden hydrological network, connected by rivers that flow beneath the ice, carrying water and potentially life from one lake to another. This is not the ocean, exactly. These are freshwater environments, cut off from the sea. But they are connected. Water from these lakes eventually drains beneath the ice shelves and into the Southern Ocean, creating complex currents and pressure dynamics that could, in theory, generate acoustic events. Could the mysterious sounds originate not from the open ocean, but from beneath the ice? From water moving through subglacial channels? From ice collapsing into hidden caverns? From geological processes occurring in an environment we've barely begun to explore? It's possible. Antarctica is also home to unique oceanographic conditions. The waters around the continent are stratified in unusual ways, with layers of water at different temperatures and salinities, creating acoustic boundaries that can trap and channel sound. The ice shelves themselves act as resonant structures, massive floating platforms of ice that can vibrate and produce low-frequency sounds when stressed by tides, currents, or their own weight. Some researchers have proposed that interactions between ocean currents and the underside of ice shelves could generate the kinds of sounds detected by hydrophones. As water flows past ice, turbulence and cavitation can create noise. When ice cracks under pressure, the resulting acoustic wave travels through both the ice and the water, creating complex interference patterns. This is plausible. It fits the location, the frequency profiles, the duration of the sounds. It is, in many ways, a more complete explanation than simply attributing everything to icebergs calving from glaciers. But it is also speculative. Directly observing these processes is extraordinarily difficult. Deploying instruments beneath ice shelves, accessing subglacial lakes, even simply measuring water flow in these environments requires technology and logistics that are currently at the limits of what we can achieve.
Antarctica, for all our exploration, remains largely unknown. We have mapped its surface with satellites, drilled through its ice in a few locations, and maintained research stations along its coast. But the interior, the vast expanse of ice covering an entire continent, is as remote and inaccessible as any place on Earth. And beneath that ice, hidden from view, processes are occurring that we can only infer from indirect measurements and acoustic signals captured hundreds or thousands of miles away. It is here, in this intersection of known and unknown, that imagination begins to operate. What if the sounds are not merely geological? What if they are biological, evidence of life adapted to environments we've never explored? Creatures living in the dark waters beneath the ice, thriving in conditions we would consider inhospitable. The idea is not as far-fetched as it might seem. Life has been found in nearly every environment on Earth, no matter how extreme. Microbes live in boiling hot springs, in acidic lakes, in the frozen soils of the Arctic. Complex ecosystems exist around hydrothermal vents on the ocean floor, where sunlight never reaches and temperatures fluctuate between freezing and several hundred degrees. If life can exist in those conditions, why not beneath Antarctica ice? In 2010, researchers drilling through the Ross Ice Shelf discovered small crustaceans living in the frigid waters beneath, creatures that had somehow adapted to total darkness and near-freezing temperatures, feeding on organic matter that drifted down from above or was produced by chemosynthetic bacteria. If complex life exists there, in that harsh and isolated environment, what else might exist in the larger, deeper subglacial lakes? What adaptations might have evolved over millions of years of isolation? It is tempting to imagine unknown species, not sea monsters or leviathans, but creatures nonetheless strange and unexpected, producing sounds that our instruments detect, but that we do not yet associate with biology because we've never encountered anything like them before. This is admittedly speculation. No evidence currently supports large unknown fauna beneath Antarctica ice. The most likely sources of the anomalous sounds remain geological and cryological: ice, rock, water interacting in powerful and complex ways. But the absence of evidence is not evidence of absence, particularly in an environment as underexplored as Antarctica. And so the question lingers, drifting through the cold water like the sounds themselves. What lies beneath? What processes are occurring in the darkness under miles of ice, in waters that have not seen sunlight for longer than human civilization has existed? What might those hidden places conceal? We do not know, but we continue to listen. And perhaps one day the ice will yield another of its secrets, a sound, a signal, a piece of evidence that shifts our understanding and reveals something of the hidden world beneath. Until then, Antarctica remains a place of mystery, a frozen frontier where the boundaries of the known world blur into speculation, where science and wonder coexist, and where the sounds captured by distant hydrophones hint at processes and phenomena we are only beginning to comprehend. The ice is not silent. It speaks in its own slow, cold language. And we, standing at the edge of that frozen continent, strain to understand what it is saying.
Chapter 7. The Hypotheses. When faced with a mystery, the human mind seeks explanation. It is a fundamental drive, perhaps the most fundamental, the need to make sense of the world, to impose order on chaos, to transform the unknown into the known. The anomalous ocean sounds have generated no shortage of hypotheses. Some are scientifically rigorous, grounded in data and supported by evidence. Others are speculative, imaginative, occasionally bordering on the fantastical. All of them, in their own way, represent attempts to answer the same question: what made these sounds? Let's consider the possibilities, moving from the prosaic to the extraordinary. Hypothesis 1. Ice. As we've discussed, this is the prevailing scientific explanation. Ice, in its many forms, is abundant in the regions where most anomalous sounds have been detected. Icebergs calve from glaciers, creating powerful acoustic events. Ice shelves crack and collapse. Icebergs run aground, scraping against the sea floor. Ice under pressure fractures and releases energy as sound. The acoustic profiles of these events match many of the recorded anomalies. The locations match. The timing, in cases where satellite observations are available, often correlates with known ice activity. This explanation is parsimonious. It requires no unknown phenomena, no undiscovered species, no exotic processes. It is, in the language of science, the no hypothesis, the simplest explanation that fits the available data. Is it correct? Probably. In most cases, yes. But most cases implies exceptions. Hypothesis 2. Geology. The Earth's crust beneath the ocean is dynamic. Tectonic plates shift, creating earthquakes. Volcanic vents erupt, releasing superheated water and gas. Underwater landslides send sediment cascading down continental slopes. All of these processes generate sound, sometimes powerful, low-frequency sound that can travel great distances through water. Could some of the anomalous signals be geological in origin? Absolutely. In fact, some have been definitively linked to seismic activity, but others have occurred in the absence of any recorded earthquakes in regions with no active volcanism, at times when no geological events were detected by seismometers. So, while geology explains some sounds, it does not explain all of them. Hypothesis 3. Human activity. The ocean is not an empty wilderness. It is traversed by ships, submarines, underwater cables, oil rigs, mining operations. Military forces conduct exercises involving sonar, depth charges, and other technologies that generate acoustic signals. Could the mysterious sounds be man-made? In some cases, yes. Naval activity, particularly during the Cold War, generated a significant amount of underwater noise. Some of it was classified, not immediately attributable to known sources, and thus appeared anomalous until context was provided.
But the sounds we're discussing, the bloop, Julia, slow down, do not match known human signatures. They are too loud, too sustained, or occur in locations too remote from any documented naval or commercial activity. This doesn't entirely rule out human origin. Secret operations, experimental technologies, covert research, all of these are possible, if difficult to prove. But absent evidence, this hypothesis remains speculative. Hypothesis 4. Biology. The ocean is home to creatures of astonishing diversity, many of which produce sound for communication, navigation, and hunting. Whales, dolphins, fish, even certain invertebrates generate acoustic signals. Could an unknown species be responsible for the anomalous sounds? This is the hypothesis that captures popular imagination. The idea of an undiscovered leviathan lurking in the deep, occasionally vocalizing in ways that our instruments detect. It's compelling, romantic. It fits our cultural fascination with sea monsters and the unknown. But it's also the hypothesis that faces the most challenges. For a biological source to produce the volume and frequency profile of something like the bloop, it would need to be extraordinarily large and possess anatomical structures capable of generating sound at unprecedented levels. No known marine mammal comes close. Moreover, if such a creature exists, where is the other evidence? Where are the carcasses, the sightings, the secondary acoustic signatures that would indicate a living population? Large animals do not exist in isolation. They feed, they breed, they die, they leave traces. None have been found. This doesn't definitively disprove the biological hypothesis, but it makes it highly unlikely in the absence of additional supporting evidence. Hypothesis 5. The exotic. And then there are the theories that venture beyond conventional explanation.
Theories involving underwater alien bases, secret government experiments, portals to other dimensions, ancient technologies left behind by lost civilizations. These hypotheses are popular in certain corners of the internet, and they generate a significant amount of content: videos, articles, entire communities devoted to exploring and elaborating on these ideas. From a scientific standpoint, they are not credible. They require extraordinary assumptions unsupported by evidence. They invoke entities and processes for which there is no empirical basis. They often rest on logical fallacies and misunderstandings of how science works. But they persist, and their persistence is worth noting, not because they are correct, but because they reveal something about human psychology. We are drawn to mystery. We are drawn to the idea that the world is more strange, more wondrous than it appears. We want there to be secrets, hidden knowledge, truths that exist just beyond the reach of conventional understanding. This is not inherently problematic. Wonder and curiosity are valuable. They drive exploration and discovery. But they must be balanced with skepticism and evidence. Believing that something might be true is not the same as having good reasons to think it is true. So, where does this leave us? With a handful of probable explanations, ice, geology, human activity, and a lingering acknowledgement that probability is not certainty, the sounds are most likely natural phenomena, the result of processes we understand in general, even if we cannot account for every specific instance. Ice cracks, the earth shifts, water moves. These are the ordinary workings of a dynamic planet. But ordinary does not mean fully known. The oceans still hold surprises. There are depths we have not explored, species we have not cataloged, processes we do not fully understand. And so we hold our explanations lightly. We accept them as the best current interpretation of the data, while remaining open to revision should new evidence emerge. This is not uncertainty born of ignorance, but humility born of understanding how much remains to be learned. The hypotheses will continue to evolve. New data will refine our understanding. Some mysteries will be resolved, others may deepen. And through it all, the ocean continues to speak, in frequencies low and high, in signals loud and faint, in a language we are still learning to interpret.
Chapter 8. The Ocean as a Mirror. There is a reason the ocean fascinates us. It is not merely its size, though that is staggering: 361 million square kilometers, covering more than 70% of the Earth's surface. Nor is it simply its depth, though the thought of water stretching down more than 6 miles into crushing blackness is enough to induce a kind of existential vertigo. No, the ocean fascinates us because it reflects something essential about the human condition: the tension between the known and the unknown, between the safe shores of certainty and the vast expanse of mystery that lies beyond. We are, as a species, explorers. We have crossed every continent, climbed the highest peaks, ventured to the poles and into space. We have mapped the surface world with extraordinary precision. But the ocean, the deep ocean, remains largely beyond our reach. We have better maps of Mars than we do of the ocean floor. We have sent robots to distant moons, but the deepest trenches of our own planet have been visited by humans only a handful of times. This is not for lack of trying. It is a matter of physics. Space, for all its dangers, is relatively forgiving. A spacecraft needs only to maintain pressure and temperature, to shield against radiation, to carry enough fuel and oxygen. But the deep ocean presents challenges that are, in some ways, more severe.
At depth, pressure increases by 1 atmosphere for every 10 meters. At the bottom of the Mariana Trench, the pressure exceeds 1,000 atmospheres, enough to crush most materials, to implode submarines, to make exploration extraordinarily difficult and expensive. Water is also opaque. Light penetrates only the upper layers of the ocean. Below a few hundred meters, darkness is absolute. We cannot see, cannot navigate by sight, cannot observe directly. We rely on sonar, on cameras with limited range, on instruments that provide data, but not the intuitive understanding that comes from visual observation. So the ocean remains, in large part, unknown, unexplored, a frontier not of depth. And the sounds, these strange anomalous signals captured by hydrophones, are like messages from that frontier. Fragments of information, hints of processes and phenomena occurring in places we cannot easily access, in darkness we cannot easily penetrate. They remind us of how limited our perspective is. We stand on the shore or sail across the surface, and we imagine we understand the ocean. But beneath the waves, an entire world operates according to its own logic, indifferent to our presence, full of events and life and dynamics that we only glimpse indirectly. In this way, the ocean mirrors the broader human condition. We live our lives on the surface of things. We navigate familiar territory, our homes, our communities, our daily routines. We build structures of meaning and knowledge that give us the sense of understanding the world. But beneath that surface, so much remains hidden. Beneath our conscious awareness, subconscious processes shape our thoughts and behaviors. Beneath our social structures, deep currents of history and culture flow, influencing us in ways we rarely acknowledge. Beneath the certainties we cling to, vast unknowns stretch into darkness. The ocean is a reminder of this. A reminder that mystery is not something out there in distant galaxies or theoretical dimensions. It is here. It is all around us, beneath us, within us. And the sounds, the bloop, Julia, slow down, are expressions of that mystery, not in a literal sense, not as messages from unknown intelligences, but as acoustic evidence that the world is larger, stranger, and more complex than we often assume. To listen to these sounds is to confront the limits of knowledge, to acknowledge that despite all our science, all our technology, all our exploration and analysis, we do not have all the answers. We do not fully understand even our own planet.
This can be unsettling. The unknown is uncomfortable. Mystery creates anxiety, ambiguity, the sense that the ground beneath our feet is not as solid as we believed. But it can also be liberating. Because if the world still holds mysteries, then there is still room for discovery, still space for wonder, still the possibility that tomorrow we might learn something that changes our understanding, that opens new questions, that reveals hidden dimensions of reality we had not imagined. The ocean, in this sense, is not just a physical space. It is a metaphor for the journey of understanding, a journey that never truly ends, that always leads to new horizons, new depths, new questions. And the sounds are waypoints on that journey, markers indicating where we have been, what we have heard, and how much farther we still have to go. There is poetry in this, a kind of existential resonance.
We send instruments into the deep, hoping to capture truth. They return with data, with recordings, with fragments of information. We analyze, we interpret, we build theories, and occasionally we succeed. We identify a source, we explain a phenomenon, we expand the circle of known, but the circle of the unknown expands even faster. For every question answered, new questions emerge. For every mystery solved, new mysteries appear on the periphery. This is not a failure of science. It is the nature of inquiry. The ocean will always have secrets, not because it is trying to hide them, but because it is vast and we are small, because it is deep and our reach is limited, because it operates on scales of time and space that dwarf human lifetimes and human perspectives. And perhaps that is as it should be. Perhaps a world fully known, fully mapped, fully explained would be a diminished world, a world without wonder, without the thrill of discovery, without the humility that comes from encountering something beyond our understanding. The sounds remind us to remain humble, to listen more than we speak, to observe more than we assume, to hold our conclusions lightly and our questions earnestly. They remind us that the ocean, like the cosmos, like consciousness itself, is a mystery worth contemplating, not to solve necessarily, but to engage with, to stand before in awe and curiosity, to allow it to shape us, to teach us, to draw us deeper into relationship with the strange and beautiful world we inhabit. And so we listen, not only with our instruments, but with our imagination, not only with our rational minds, but with that part of us that responds to mystery with wonder rather than fear. We listen to the ocean, and in its sounds, familiar and strange, known and unknown, we hear echoes of our own journey through existence, a journey into the deep, a journey without end. Chapter 9. The Signal That Never Ended. There is a particular sound in Noah's archive that deserves special attention, not because it is the loudest or the most mysterious, but because of its persistence. It is called 52 Blue. Unlike the Bloop or Julia, 52 Blue is not a single event. It is an ongoing phenomenon, a sound that has been detected intermittently for decades, always at the same frequency, always following similar migration patterns, always alone. 52 Blue is the nickname given to a whale, likely a blue whale or a hybrid of blue and fin whale, that vocalizes at a frequency of 52 hertz. This is significantly higher than the typical range for blue whales, which call at frequencies between 10 and 20 hertz. The whale was first detected in 1989 by naval hydrophones. Year after year, the same distinctive call appeared in the data, tracking a migration route along the Pacific coast of North America. The frequency, the timing, the pattern, all suggested a single individual returning season after season, calling into the ocean. But here's what makes 52 Blue poignant. The frequency is too high for other whales to hear easily. Blue whales communicate at extremely low frequencies, specifically because those frequencies travel farther underwater, allowing them to maintain contact across vast distances. A whale calling at 52 hertz would be audible to others, but perhaps not recognizable, perhaps not interpreted as communication, perhaps not answered. 52 Blue has been called the loneliest whale in the world. For more than 30 years, this whale has been tracked, its calls recorded, its migrations mapped. And in all that time, there has never been evidence of a response. No other whale has been detected calling at the same frequency. No companion has appeared in the data. Just a single voice calling into the deep, year after year, seemingly unanswered. The story of 52 Blue has resonated with people around the world. It has inspired documentaries, songs, art projects, and countless social media posts. People see themselves in this whale, the sense of being unheard, of speaking a language no one else understands, of searching for connection and finding only silence. It is, of course, possible that we are anthropomorphizing, projecting human emotions onto an animal that may not experience loneliness in the way we do. The whale appears healthy, continues to migrate, continues to call. Perhaps it is not lonely at all. Perhaps it is simply different, adapted in a way that sets it apart but does not cause suffering. We cannot know. But the story of 52 Blue illuminates something important about sound, about communication, about the nature of signals sent and received. Because sound, in the ocean or anywhere else, is only meaningful if someone is listening. A call without a receiver is just noise. A signal without interpretation is just data. The mysterious sounds, bloop, Julia, slow down, may be similar. Not intentional communication, not messages, but simply events. Phenomena that generate acoustic waves that travel through water, encounter hydrophones and are recorded. We listen and we try to understand. We analyze the frequency, the amplitude, the duration. We search for patterns, for meaning, for something that will allow us to say, this is what it was, this is what it meant. But perhaps the sounds mean nothing. Perhaps they are like 52 Blue's call. Expressions without intention, signals without message, just the natural output of processes that have no awareness of being heard. Or perhaps they mean something we do not yet have the context to understand. Language, after all, requires shared context. A word means nothing if you do not know the language. A symbol means nothing if you do not know the code. When SETI, the search for extraterrestrial intelligence, scans the cosmos for signals from other civilizations, they face this challenge. How do you recognize a message when you don't know what language it might be in, what form it might take, what patterns might indicate meaning? You listen for anomalies, for signals that stand out from the background noise, for patterns that seem too structured to be random. And then you analyze, you hypothesize, you test.
But you also acknowledge that you might be listening to the cosmic equivalent of 52 Blue, signals that are real, that are being transmitted, but that you lack the context to interpret. The ocean sounds may be similar, real phenomena captured and recorded, but operating outside the framework of our current understanding. Not messages, not warnings, not communication, just the acoustic fingerprint of a world that exists whether we listen or not. And yet, we keep listening, because even if the sounds mean nothing in a communicative sense, they mean something to us. They represent mystery, possibility, the unknown. They remind us that the planet we live on is not fully domesticated, not fully understood, not fully within our control. They remind us that there are still voices in the dark, still signals traveling through the depths, still phenomena occurring that we can detect but not always explain. And perhaps, most importantly, they remind us of the value of listening itself. Not listening with the expectation of understanding, but listening with openness, with curiosity, with the willingness to sit in the discomfort of not knowing, and to allow mystery to exist without immediately demanding resolution. This is a difficult practice in a world that values certainty, that rewards answers, that treats mystery as a problem to be solved rather than an experience to be savored. But the ocean, in its vastness and depth, teaches us differently. It teaches us that some questions take decades to answer, that some phenomena require patience to understand, that some mysteries may never be fully resolved, and that this is not a failure, but simply the nature of a complex and dynamic world. The signal that never ended, whether it's 52 Blue's solitary call or the faint recurring anomalies in the hydrophone data, is a reminder that the world is full of ongoing processes, continuing stories, phenomena that unfold over timescales longer than human attention spans. We capture moments, we record fragments, we analyze snapshots. But the ocean story is continuous, unbroken, eternal. And we, with our brief lives and our limited perspective, are privileged to listen to even a small part of it. So we continue to monitor, we continue to record, we continue to analyze. Not because we expect to solve every mystery, but because listening is its own reward. Because in the act of paying attention, of caring enough to notice, of being curious enough to investigate, we honor the complexity and wonder of the world we inhabit. The signal continues, and so do we. Chapter 10. Dreams Beneath the Static. The ocean is breathing. Not in the way we breathe, drawing air into lungs, expelling carbon dioxide, the rhythmic exchange that keeps us alive, but breathing nonetheless. Rising and falling with the tides, currents circulating like blood through a vast planetary body, heat and cold exchanging across invisible boundaries, the whole system pulsing with a slow, ancient rhythm. And beneath it all, the sounds. The pops and clicks and groans and whistles and rumbles and tones that make up the ocean's acoustic signature. The language of geology and biology and fluid dynamics translated into frequencies that travel through water and time, carrying information we are only beginning to decode. We have spent this hour together exploring a handful of these sounds, anomalies that stood out from the background, phenomena that resisted easy explanation, mysteries that captured our imagination and reminded us how much remains unknown. The bloop, with its organic waveform and impossible volume. Julia, descending through frequencies like a sigh. Slow down, fading across 7 long minutes. Whistle, sharp and brief. 52 Blue, calling into darkness year after year. Each sound tells a story, or rather, each sound is a story, a narrative written in frequencies and amplitudes, a tale told in the language of physics and translated, imperfectly, into human understanding. Some of these stories have endings. The bloop, probably ice. Julia, likely ice. Slow down, almost certainly ice. But endings are not the same as conclusions.
Because even when we identify a probable source, even when we match an anomaly to a known phenomenon, the sense of mystery persists. Perhaps this is because the ocean itself is a mystery, not in the sense of being unknowable, but in the sense of being inexhaustible. Every answer reveals new questions. Every exploration uncovers new territory. The more we learn, the more we realize how much remains to be learned. And perhaps this is as it should be. Because a world fully known would be a world fully mastered, and mastery implies control, dominance, the reduction of the wild to the domesticated. The ocean resists this. It is too vast, too deep, too powerful to be fully controlled. We can study it, measure it, map it, but we cannot tame it. It remains, in essential ways, beyond us. And the sounds, these strange, beautiful, unsettling signals, are reminders of that wildness, evidence that the ocean has its own voice, its own rhythms, its own processes that unfold regardless of whether we are listening. This is humbling, but humility, properly understood, is not diminishment. It is perspective. It is the recognition that we are part of something larger than ourselves, that our knowledge is partial, that our experience is limited, and that this is not a flaw, but simply the condition of being human. To listen to the ocean is to practice humility, to acknowledge that we do not have all the answers, to sit with uncertainty, and to find within that uncertainty a kind of peace. Because certainty, for all its comfort, is often an illusion. The world is not static. It is dynamic, changing, full of processes that operate on scales we can barely comprehend. Certainty in such a world is not wisdom. It is blindness. Better to remain open, to listen, to wonder. The sounds we have explored tonight may be explained, but they are not diminished by explanation. Ice cracking and grinding and collapsing is itself extraordinary. The forces involved, the pressure, the scale, the energy released are staggering. To hear these events recorded across thousands of miles is to witness the power of natural processes that have shaped the planet for millions of years and will continue long after we are gone. And if some sounds remain unexplained, if some anomalies resist our current understanding, that too is valuable. Because those are the sounds that pull us forward, that invite further investigation, that remind us why we became scientists, explorers, listeners in the first place. Not for the satisfaction of knowing, but for the joy of discovering. Not for the comfort of certainty, but for the thrill of standing at the edge of the unknown and taking one step further.
The ocean, in this sense, is a teacher. It teaches patience, because understanding takes time, and the ocean's processes unfold over timescales that dwarf human urgency. It teaches humility, because no matter how sophisticated our instruments, no matter how comprehensive our data, we remain students before its vastness. It teaches wonder, because in its depths, in its sounds, in its mysteries, we encounter something that transcends the ordinary, that reminds us how strange and beautiful and improbable existence is. And it teaches us to listen, not just to the ocean, but to the world, to pay attention, to notice, to be present. These are lessons worth learning. So tonight, as we drift toward the close of this exploration, let us carry these lessons forward. Let us remember the bloop not as a monster or a hoax, but as a sound captured in 1997
that challenged our assumptions and invited us to look more carefully at the world around us. Let us remember 52 Blue not as a symbol of loneliness, but as a reminder that difference is not deficiency, that to speak a unique language is not to be voiceless, and that we cannot always know what our signals mean to those who might be listening. Let us remember the scientists, patient, curious, dedicated, who spend their lives listening to the ocean, maintaining the instruments, analyzing the data, asking the questions that move us incrementally toward understanding. And let us remember the ocean itself, vast and deep and full of secrets, speaking in frequencies we are learning to hear, inviting us to explore, to wonder, to remain forever curious about the world we inhabit. The sounds continue. The ocean breathes. The mystery persists. And we, standing at the edge of the water, listening to the echoes from the deep, are richer for having paid attention. Thank you for drifting with us tonight into the dark water and the strange sounds that rise from the abyss. If this exploration stirred something in you, curiosity, wonder, a desire to learn more, we invite you to continue the journey. Share your thoughts in the comments below. What do you think these sounds represent? Have you heard something in nature that defied easy explanation? We'd love to hear your perspective. And if you enjoyed this quiet dive into mystery, consider subscribing. We'll continue exploring the boundaries of the known and unknown, the places where science meets wonder, and the questions that remind us how much remains to be discovered. Until next time, keep listening. The world is full of signals, full of stories, full of voices calling from the deep. All we need to do is pay attention. And perhaps, in the act of listening, we'll learn not only about the ocean, but about ourselves, about what it means to be curious, to be humble, to stand before mystery and feel not fear, but awe. Thank you for listening, and may your own journey into the unknown be filled with wonder.